Hi, today we are going to see the manufacture of nitric acid. What is the difference between manufacture and laboratory preparation? Again, laboratory preparation is in a small scale, manufacture is in a large scale. Okay. The manufacture of nitric acid is by Ostwald's process because he was the one who found it, and this is made of 3 steps. The first step is catalytic, step 1. That is catalytic. This is nothing but the catalytic oxidation of ammonia. So we take ammonia, is burnt in oxygen in the presence of a catalyst like platinum, and the temperature is around 800 degrees to give nitric oxide and water vapor plus a lot of heat. Over here 12, so 6 here, 6 plus 2, so there are 5 oxygen molecules. Now in this catalytic oxidation, the catalyst used is platinum. That's one thing that you need to remember. The second one is this reaction is highly exothermic. Therefore, initial heating is enough. After that, the heat that is evolved will take the reaction to completion. That is step 1. The next one is step 2, which is oxidation. So what happens in this oxidation is this nitric oxide reacts further with oxygen to give nitrogen dioxide at a temperature of 50 degrees. Why this 50? Because higher temperatures can lead to the decomposition of nitrogen dioxide. So we prefer 50 degrees. So 2 and 2 here. Yeah. So this is what happens in the second step, that is oxidation. Next we move on to step 3, which is absorption. This nitrogen dioxide is absorbed in water in the presence of oxygen plus water in the presence of oxygen to give you nitric acid. This is at room temperature. So 4 here, and because this is 4, yes. Okay, so this nitric acid that is formed here is 68% nitric acid, and this further is converted to 98% fuming nitric acid by the addition of concentrated sulfuric acid, which is a dehydrating agent that would remove the molecules of water. 2 things that we need to make a note of is a higher ratio of air is used. Why is a higher ratio of air used? Because we are not taking oxygen but we are taking air. 1/5 of the air is oxygen, so only 1/5 is available. The second reason being all the 3 steps need oxygen for the reaction to happen. So that's why we use a higher ratio. And initial heating is enough because it is highly exothermic. So these are the things that we need to make a note of, and this is how nitric acid is manufactured by Ostwald's process. Next we move on to the properties of nitric acid. As we earlier saw, pure nitric acid is colorless but gets an yellowish tinge on standing, becomes yellow. And why does it become yellow? because it easily decomposes to give nitrogen dioxide. That is the reason for the yellow coloration. Okay, being an acid, it would turn blue litmus solution or anything, any paper turns red. Okay, methyl orange will turn from orange to pink. Okay, phenolphthalein stays colorless. Alright, so these are the general things that we need to know. One more thing that we can do is, if it falls on the skin, this is just a general thing that you need to know. If it falls on the skin, nitric acid reacts with the proteins of the skin and it forms a yellow colored compound called xanthoprotic acid. This causes a yellow coloration. Skin becomes yellow. Okay, so this is when it falls on the skin. Now we go to the most important property. Nitric acid is a strong oxidizing agent. How does it work as an oxidizing agent? When we take nitric acid, it breaks down to give nitrogen dioxide plus water vapor plus nascent oxygen. Here. What do you mean by this nascent oxygen? This nascent form of any element is the most active form. It is, the other meaning for this is it's inborn. So within the system it is born. It is like, there's a baby in the mother's womb, very much alive and active, but we cannot see that. So this nascent oxygen is not seen outside, it's not available outside, but within the system we have this. Now with this oxygen, this nitric acid can react, add on this oxygen to various compounds, so oxidize them, thereby it reduces to different compounds like say NO2 or NO, or it can reduce to various kinds of oxides of nitrogen depending on the concentration of nitric acid. That is the speciality of nitric acid. Now let us see the oxidizing reactions of nitric acid. With non-metals, there are two things that we need to learn. One is with carbon and the other one is sulfur. Okay, so when nitric acid reacts with carbon, remember both the things, the oxidizing property is evident only when it is in the concentrated form. Now when it reacts with carbon, carbon would combine to give carbon dioxide with oxygen. Hydrogen can be oxidized to water. Then of course we have nitrogen dioxide. So to make it here 12. Yes. Okay. So this is the reaction that happens with carbon. So it is oxidized to give you these are the products. Now when it reacts with sulfur, sulfur reacts with nitric acid, again concentrated, to give you sulfuric acid plus water plus nitrogen dioxide. Okay, because here also there is one more, so we add 6 here. This is again 2. This would be 6 now. 12, 14, 18. Yes. The speciality of this reaction is this sulfur being a element, it forms its own acid, sulfuric acid. Now this is volatile, nitric acid is volatile. This gives rise to a non-volatile sulfuric acid. Why is this acid not being formed here? Because here if we form it would be carbonic acid, which is highly unstable and it breaks down into carbon dioxide and water vapor. Now the one metal that we have in our syllabus is with copper. It can form, nitric acid can reduce to two different oxides based on the concentration of nitric acid. The first one is copper reacts with nitric acid, which is concentrated, to give you copper nitrate plus water plus nitrogen dioxide. In this, it is hot concentrated nitric acid. Okay, here 2 is there, so 2 here. Yes. One thing that we need to see here is copper is oxidized, hydrogen is oxidized, nitric acid is reduced to nitrogen dioxide, and this is reddish brown. Copper, but this solution would become blue here, and there are reddish brown fumes when it is heated. Copper reacts with cold dilute nitric acid to give you copper nitrate again and water, but this time it is nitric oxide in the place of nitrogen dioxide. Okay. Comes 8, 6, 2 and 4. So depending on the concentration of nitric acid, the oxides of nitrogen formed also are different.